In this beaker, we have some solid sodium chloride. In a moment, pause the video clip and work out what kind of structure and bonding you would expect in sodium chloride and why. Pause it now and think. So, sodium is a metal, 2,8,1. Chlorine is a non-metal, 2,8,7. So you would expect sodium to lose its one outer shell electron, which should be transferred to the outer shell of a chlorine atom to make Na plus and Cl minus ions. The very, very strong electrostatic force of attraction between those oppositely charged ions would need a huge amount of energy to be broken. So you'd expect sodium chloride to be ionic, bonding with giant ionic structure and a high melting point, which makes sense because it's a solid at room temperature. If we were to talk about the structure of that lattice, it would look like this. So every sodium ion is surrounded by chloride ions. There would be 6 chloride ions. You can see 4 of those there, then there would be 1 above and 1 below. And that's the same for every chloride, 4, 5, 6, all the way through that lattice. Now let's imagine what we would do if this sodium chloride was added to water. Now sodium chloride notoriously dissolves well in water. We know this from everyday life, salt water, brine solution and so on. So let's take this measuring cylinder. It is absolutely full to overflowing here. I might just manage to get one more drop of water at the top there. 2, 3, 4, 5. I don't add any more because that's overflowing. So let's see what happens if I take a spatula of sodium chloride and add it to the water. I need to be careful that I don't drop it everywhere. Let's go. Still not overflowing. Let's add another one. Still not overflowing. Let's add a few more. And I can add a surprisingly high number of spatulas of sodium chloride, and yet it still doesn't overflow. So what's happening? Well, this sodium chloride, as you might be able to see with the mixing here, is forming a solution. So we would say that sodium chloride is the solute, water in the measuring cylinder, the solvent, and the sodium chloride in the middle, mixed in with the water, the solution. And let's have a little picture of this and see what happens to this lattice when that actually happens. So if you look at this picture, hopefully you could see that the positive ions attract the water molecules in this way, and the negative ions attract the water molecules in this way. That the negative chloride ions always attract the hydrogens from the water, and the positive sodium ions always attract the oxygen atoms in the water. That's because water is said to be polar, and so these hydrogens, even though this is a molecular substance, they're ever so slightly positively charged, so they form an attraction here, and the oxygens are ever so slightly negatively charged, so they form attractions here. So what happens when this stuff dissolves, just like it did in the measuring cylinder, is that the lattice dissociates. So the ions are moved apart from one another. It breaks those strong electrostatic forces of attraction. But what happens here is that new attractions are made with the water molecules within that solution. And so we just mix together Na pluses, Cl minuses, and loads of water within this solution. So to recap, sodium chloride, this stuff here, the solid which was added, is the solute. The water into which this solute dissolves is the solvent. The product of all of that, the mixture of the water molecules and the Na plus and Cl minus ions, is called a solution. Importantly, this is a physical change. There's no chemical reaction here. All that's happened is these ions, instead of attracting one another in that fixed position in the lattice, they've just moved apart from each other and been surrounded by waters. If we remove the water, then the water disappears, those ions come back together just like this in a giant ionic lattice. So this is a physical change, producing a mixture, not a reaction, no new substances are formed, just a different mixture of those existing substances.